So good morning. Matrices. We can solve linear equation using matrices. In Form 1 and Form 2, we look at how we can solve linear equations using substitution method, elimination method, and also graphical methods. Now, in Form 3, now we use matrix method. How do we go about it? The first thing, we write the coefficients of x and y down. So we write 3 here, that value that is close to x. For the first line, we'll have 3, these 3 here. Then close to y, we have 1y. So just write 1. Down, you write 1x, you write 1, and then y there 1. Then you enclose that in brackets, put it in this format. And then we write the unknowns, the variables x and y. Put that one in brackets. That, and then we put the equal sign, and then we write up is -2, down is 2. Sorry, 2. Once we have done that, we get the determinant of this line here. The determinant, how do we get the determinant? We get the difference of leading diagonals minus the following diagonals. So determinant there, we say determinant is therefore equals to 3 times 1 that one here minus 1 times 1. 3 times 1, you get 3. Minus 1 times 1 is just 1. So that becomes 4. Sorry. 3 minus 1 is 2. That is the first step. So the second step is that we'll get the inverse. So we get the inverse of the determinant. Inverse means you divide that number by 1, and then you put the value down. And then once we found the inverse of the determinant, we get the inverse of the original matrix. See, this is 3, 1. So 1 goes where 3 is, and 3 comes down. So that becomes 1, 3. Then 1, since the following diagonals 1, 1, they remain the way they were, but what changes is the sign. If they were positive, like this case, they were positive, they changes to be negative. And if they were negative, they becomes positive. So this one, if we work out that, this half is going to multiply everything that is inside there. So we say half times 1 is just a half. Half times that becomes negative half. Half times 1 becomes negative half. Half times that becomes 3/2. So that is the inverse of the matrix. If at all the question was to find the inverse, we will have stopped there. But now this case, we want to not solve the equation. So we use this inverse to multiply both sides. You put it here, you also put it here. We multiply the inverse with everything. So if you multiply on your left hand side, this left hand side, you will get the identity matrix, which is 1, 0, 0, 1. That one we don't write, we just leave it. Even if you write it, there's still no problem. So we say x, what is remaining on your left hand side is just x, y. X, y. That is equivalent to, we start with the inverse that we found, that is a half half, negative half, negative half, 3/2. So that is what we multiply with what is in front here. We put -2, and 2. Now, when you're multiplying matrices, you should know that we multiply row times column. We might use the row here times the column. So meaning that we'll have here, this I have here will multiply that, and then this one goes with this. Whatever happens up is also going to happen down. So simply what we're saying there is that I have times -2 plus -1/2 times 2. That is for upwards. Coming downwards, we'll have -1/2 times -2 plus 3/2 times 2. So this one here cancel that, becomes -1. 2 cancel that, becomes 1. This 2 cancel here, 1 goes there, -1. Therefore 2 goes with this, becomes 1. Therefore you will realize that our x, the matrix of x to y, we don't put the division sign, will be equivalent to, up here I have -1. Remember, -1 plus -1 becomes -2. Down here we have negative times -1. -1 times -1 is +1. +1 plus 3 is +4. So our x and y, even if we use the elimination method, you will still get the same answers. But if you are told to use matrix, then you are supposed to use matrix method. If you use elimination method, what will happen to you is that it will be wrong. You haven't followed their instruction. The step, get the determinant, inverse, and then multiply it with inverse. Thank you.